Okay, let's go ahead and get started. I don't know if all you guys were in the keynote, so hopefully I don't have to reintroduce myself and all my personal things and so forth. I'm Bob Ward, work for the Microsoft Corporation as an architect. I have to warn you that this will be a lot more fast-paced than the keynote, a little more technical than what I presented this morning. What I'm going to talk about today is a topic called extended events, which I consider the new tracing architecture for SQL Server, replacing SQL Trace and SQL Profiler. Like I said, this is going to be a little more faster pace in the keynote. It's going to make some basic assumptions about some of your fundamental knowledge of SQL Server. So I apologize if I dig into something that's pretty detailed and it's something you've not dealt with SQL Server. I certainly entertain your questions, unlike the keynote, during the talk. But if I feel that it's kind of slowing us down where we can't get through some of the demos, because I really want to demonstrate some of this for you, then I might have to defer it till the end. All of my talks and demos and scripts for any of these sessions I'm providing to the conference, but at any time, if you struggle to get those, you can always email me at bobward@microsoft.com, and I'm happy to provide all of these to you. Come on in. If you come in late, you go sit in the front. Just kidding.
Fair enough.
Just kidding. Okay, so what are we going to cover today? I'm going to actually spend a little bit of time explaining a little bit about extended events and a little architectural of what it does and what it is and why we did this. But the meat of the talk is to talk about scenarios, to give you specific situations where this tracing functionality can help you with SQL Server. I'll talk about doing a performance analysis on a live server, like a live situation. TempDB usage, an actual memory leak scenario. We'll talk about the system health session. And then something that's a pretty advanced topic, but you might find interesting about debugging something called Spinlocks. This bonus more X event, we won't get to. I'm sure there's no chance we'll finish this. We have 75 minutes, but we won't get to that today. But I included it for your knowledge when you look at the decks afterwards. If I think about X event, and I call it X event, that's a code name we use at Microsoft for extended events. I think in terms of these four things that it can provide you in using SQL Server. One, you can monitor the server using this technology. Certainly you use other tools and techniques to do that, but it can provide you that capability. Definitely used to troubleshoot problems. We do that with our support team. I think you can do that as well. Third, debug problems at a little more advanced level, like we'll talk about Spinlocks. And then finally, just learn about the product. I mean, people use X events all the time to trace certain things and just understand more details about how the server works. I don't know if you guys follow this TV show, Big Bang Theory is my favorite television show. So let's talk about explaining X events, perhaps maybe not I'm awakening you to Penny and I'm Sheldon, that's not for sure. So why do we do X event? Well, first of all, trace and profiler are marked for deprecation. Doesn't mean that they're still not in the product and they're not completely removed, but we're not making any more advancements to that technology. So we need something to replace it for the future, and extended events is that technology. It's definitely faster and more scalable than SQL Trace. We actually built the X event technology in conjunction with the SQL OS team to be just that, to be extremely scalable and fast. Designed not to cause server problems. Maybe today you've used SQL Trace before in a high-end server and it's actually caused you issues. We designed X event in such a way that it wouldn't do that. Definitely more events than SQL Trace ever had. I mean, we've created parity with SQL Trace, but we've got far more events than Trace was designed for. And then this concept called targets and actions make it more powerful than Trace had, and I'll explain that in a second. And then Management Studio, starting with 2012, contains the basic user interface tooling that SQL Profiler provided for you before. So if you have to learn more about X events, you got to understand the objects that are part of the system. First of all, you just have events. And really, event, if you have to think of most simplest form, is an instrumentation point in our code. So somewhere in our source code, we say, hey, when this thing occurs in our code, let's fire an event if they're tracing it. As an example, SQL statement completed is when you actually finish running a query. There are 763 events in SQL 2014. And it is a parity for SQL Trace Plus. There's a bunch of other things that SQL Trace never had that we've added. Second is something called an action. So if you're using extended events to trace an event and you would like to collect more data that's orthogonal or independent to the event, you would use something called an action. SQL text as an example, you can have, for example, a event for a page split, and then you can add the SQL text action to figure out what query caused the page split, even though the SQL query SQL text data is not part of that event in the code. Create dump all threads is an example of an action where we actually take some action. We will collect an actual mini dump at a given point in time an event is fired, as opposed to just collecting it in the context of seeing the event data. Predicates are how you do filtering. But if you want to do filtering independent of the fields that are collected, like in the case of a page split, you would have the page ID or the page number. You could actually do filtering on fields that are independent of the event, like a database ID or a session ID. You could say, for example, only show me the page splits for database ID 5, even though the page split event doesn't include database ID in its data. And then this is the really part that's really cool feature of Xevent is called targets. This is really the data storage for where you store your event data once you collect it. And some of these targets are what I call smart targets. So for example, the basic file storage target is called event file. But if you want to collect data in a way that we store automatically a histogram, you would use the histogram target. So it's an aggregation by default that we do for you versus you having to store it in a file and build your own histogram. And then finally, maps. This is really interesting. A lot of events have different codes. Like a wait type has a number associated with it. And if you want to find the corresponding name of that type, of that code, you would look at the map data to go figure that out. So those are the basic objects. Well, what about the architecture of what we did? How did we build this thing? The SQL OS team built it, and the core guts, the core architecture of extended events exist in the Xevent engine, which is in SQLDK.dll. So what you're looking at right here is a couple of pieces of either data or code in Xevent that make this powerful. So first of all, the Xevent object catalog is actually stored in memory. It's not on disk. So when you run a dynamic management view query against SQL Server, you can find out what's in the Xevent data itself. These are background processes, XE timer and XE dispatcher, that are going to be used to actually store data in these targets to the right over here. So if you use Management Studio to fire off and create an event session, you are going to store the metadata of that event session in the master database. So that's the only thing that's ever persisted on disk for Xevent from a metadata point of view is the definition of your session. When you start the session, what we're going to do is we're going to take the catalog data in master, and in memory we're going to build metadata about your session, and that's going to include several memory buffers that are associated with that session. And if you create a second session, it will have its own separate associated set of memory buffers. So when we fire an event in the code, when we see a particular instrumentation point that we need to go fire an event, what we do is we say, okay, is the event enabled in one of these sessions? Okay? Then we'll evaluate any predicates that you provided with it to decide whether we give it to you, because you had some sort of where clause. And then we'll go off and fire any actions that you specified with it. And we'll store it in these buffers. Now, if it's an asynchronous-based target, which a file target and a ring buffer target are those, the way this works is we'll store your event data in these buffers, and the XE dispatcher background task will take the memory buffer and write it out to these targets asynchronously. If you do a synchronous target, like a counter target, which just counts the number of events, it is synchronously done as part of firing the event. So, for example, if you're just counting the number of page splits, when the page split occurs in the SQL Server engine and you have a synchronous event, as part of doing the page split, we'll write out that counter data to that target. So you got to be careful on synchronous targets because it could have some impact on your server. Fortunately, there are not many synchronous targets. In fact, counter is only one of two of them. And counter is very lightweight because we're just incrementing the number of times an event has actually occurred. And then finally, when you use Management Studio to go query things, we're going to potentially go after this memory of your event session to show you metadata about it, or the event catalog to find out information about that's possible for you to add new events or objects in your event sessions. So I thought you might find it interesting. No one really understands kind of how this works behind the scenes, but this is the basic architecture of Xevent. Okay, so let's dive into these scenarios because that's really what's more interesting to you about what are some of the scripts and different situations where you might use extended events. So let's talk about tracing the performance of a live server. One thing I should step back and tell you a second is that in your scripts, I have a set of queries for you on how to find out the different types of objects in Xevent. It's kind of boring to show you, so I didn't really think about demoing that to you. But it gives you examples about how would I find out example for all the different events that are associated with errors, if I wanted to track errors in SQL Server, or page splits or whatever. So you can go look at those scripts after the fact. It's not really interesting to actually show you. What's more interesting is show you actual scenarios. So if you think about performance of a live server, and what I mean by live server is that you're going to trace something that's going on at the time it happens versus later after some event. You know, if you try to do this, there's some limitations from some of the tool sets we use, like SQL Trace is pretty heavy. So Xevent actually might be a very, very good choice to look at things from a live perspective. What's interesting about SQL 2012 is that Xevent provides something called a streaming target that I didn't show you on there. A streaming target is not something that you define yourself. It's when you go into Management Studio and try to go view target data from a live perspective that behind the scenes we use this streaming target. And this is how we provide the basic UI to look at data for events. We provide things like grid results to see the basic showing of the data. You can do grouping, aggregation, and filtering. And you can even actually merge and export the data to Excel if you'd like to after the fact. So let me back up here. So let me stop for a second and do a demonstration before I talk about query hashing. So I need to duplicate my screen. Whoops. Nobody wants to see that. Okay, let me duplicate it. Okay, this is a fairly lengthy demo. All my demos that I do, I try to provide README files. Let's just bring this up so we make sure that we're studying the right thing here. Well, that's the object queries. That's not all that interesting. Okay, so I've got an Xevent session, and in all these situations, I'm not going to show you, for most part, the details of the scripts for Xevent, because you can see that yourself just by looking at my examples. In some cases, I'll show it to you. This one, probably not. But I've already got this Xevent session built, and when you have event sessions built in Management Studio, you can go to the Management tab here and see with extended events what sessions I have defined. So right here, when you see these sessions, these are what's stored in your master database as ones you've created. And then, of course, you have a red light to indicate if it's running, or a green arrow indicating it's red light indicating it's stopped, and a green light indicating you've started the session. So you create a session, and then you have to start it up so that you actually collect data. So this live server debugging is what I've already got built. So what I'm going to do is I'm going to fire off this repro of a problem I have that I consider a performance problem. And you're going to notice here when I kick this thing off that under Task Manager, I've got pretty heavy usage of CPU and disk going on with SQL Server. So I'm going to go over here, and I'm going to go do live debugging. Actually, let me do this. To really make this more relevant, let me start it first. And then I'll kick this off. Okay. So I'm going to kick this thing off. It looks like it's some interesting performance going on. And what I'm going to do is I'm going to right-click here and say Watch Live Data. When I say Watch Live Data, this is using that streaming target I talked about. So literally the server, we're using Management Studio to talk to the server to get a stream back of live events going on with SQL Server while it's actually happening. And I'm going to let this thing run until the repro completes. Should just take a few seconds. And as you see, it's giving you a feed of different types of events that are going on. And what I'm doing is I'm tracing different queries that are going on. And I added an event called inaccurate cardinality estimation. Because in my experience, I suspect that performance problems could be caused by cardinality estimation. So I'm going to add that in there while it's running. So this thing is finished. And when it's finished, what I'm going to do is something interesting. I'm going to go ahead and stop the session, but I've still got this live data available to me right here in this window. And when I do that, Management Studio provides some interesting options for me. I can group information in this set of events. And let me say I'm going to go ahead and group by statement. If I group by statement, I also can do aggregation. So what I'd like to do is take the duration, the average duration, and I'm going to sort it in descending order to find what are my worst performing queries. And if I see what I've provided here, this procedure, Go Cowboys, is actually the worst performing query with this average duration. If I look down here, there's 3 instances of that. If I look down here, I have other instances of other queries that have smaller durations. So it may be logical for you to go look at this and go, oh, there must be some problem with this thing. I should probably look at it. And in fact, what I can do is I can take the grouping off momentarily. And I can do something interesting. I see this inaccurate cardinality estimation that sometimes shows up with these events that I just mentioned. I'm tracing that. But how do I find out which query might have an inaccurate cardinality estimation? Well, there's something called activity ID that Xevents provides that allows you to associate one event to the next. So what I'm going to do is I'm going to group by activity ID instead, see what I get. And then I'm going to do the aggregation on the same duration. And I'll notice here that in this particular case, I've got 3 and 10. If I look at this particular one, you might find interesting. I've got one statement in here that has a bunch of these cardinality estimation problems, and it's an insert command. And if I go look at the actual query itself, if I expand this out, I can see it's using this @RomoQB. Well, if I go look at the actual stored procedure, what you're going to find that that's a table variable. And maybe if you listened to my keynote today, I talked about one of the common issues with cardinal estimation are table variables. So as it turns out in here, this is a stored procedure where I'm inserting into a table variable and using a select statement, and the estimation is off. So I've got an example when you take a look at it that you can use option recompile as part of this to avoid and get a better estimate of what's happening. So I quickly just looked at this one query that's really, really bad, and I can tell that I've got a cardinality problem with it. And I can go look to see one of those patterns I've already talked about and showed you that can exist. You can look at that in the keynote talk. You can see those examples I provided. And you can say, hey, that's how I go fix this particular problem. But I suspect by looking at this data, it's not just this query. Let's say that I fix this problem. And I rerun that workload, and I still have some high CPU that I'm trying to troubleshoot. But not one statement showed up earlier as being a problem like this Go Cowboys problem. So let me take the grouping off here and show you an additional way to look at data. Remember before, I grouped by statement. Okay? I grouped by the statement text itself. What if I group by something called query hash instead? And I do the same thing for the aggregation. Now if I do it this time, I can see here at the top, I've got a couple of queries that look like possible suspects. And one is right here, and the second is right here. Actually, that's not what I'm looking for. Let's see, this might be it right here. Yeah, this is what I was looking for right here. Oops. So if you'll notice a pattern here of this query, notice that the query is the same, except the where clause has a different constant value. Now, when I looked at this at a statement level, when I grouped by statements, these showed up all individually as different statements, which is true. They're all different statements. But would you agree this is pretty much the same query, right? As it turns out, query hash is a way to look at the query that appears to be the same, except it just differs by its maybe condition or the where clause query. And so if I'm doing a performance analysis, I might have thousands of these that all run maybe say 1 second, but cumulatively that's actually slow for my server because it's run thousands of times. If you actually can go group on this query hash, we actually hash the statement into the similar thing because we view this as being the same. This value here, if you parameterize this, is really actually a parameter at something, right? This is really the same query, not different queries. If you were to optimize this, you wouldn't go optimize each one of these. You would try to optimize the single query that is parameterized. Does that make sense? So query hash is a very efficient way to look at things versus just looking at the statement text itself. So that's kind of just a quick example, not complicated, about doing live debugging. And this is just a slide to give you a feel for what query hash is all about, where when you take a look at these particular queries right here, the statement text is different, and there's two different entries actually in dmexec stats, but the query hash itself is the same. So even looking at DMVs, you should consider looking at query hash and query plan hash to actually find like queries that are really could be parameterized to be the same actual statement. And then this is the comment about incorrect cardinality estimation. And it's raised basically when we see a significant difference between what we estimated the number of rows for an operator or a query and what the actual number of rows that are returned. You should know that this could have an impact on query performance just running this all the time. So I generally only turn this on if I suspect there's actual performance problem going on and I want to drill into the issue. So that's one scenario. Let's talk about TempDB. This is one that I find to be a very interesting common situation that customers talk to me about. So I call it the dumping ground for the engine, and what I mean by that is that there's all sorts of different reasons why TempDB could get used in your environment based on your application. And one of the things that you can see by looking at some of the dynamic management views is you can see user data, which is like standard temporary tables, or internal data, which are things like sort spills, work tables, work files, version store, all sorts of scenarios where we use TempDB for internal reasons versus just user data. And you can look at these DMVs to see it based on a file basis or a session basis. But how do you know what is using TempDB? Let's say that in this DB session space usage DMV, you saw a high amount of user data being done. Well, how do you know what queries are the ones that are chewing that up? Or internal data, the same type of thing. There is a new ability in Xevent to track this down. There is an extended event called allocation ring buffer recorded event. That's a long name, allocation ring buffer recorded. And when this trace flag is turned on, we will record information about TempDB allocation, specific to TempDB. And you could use Xevent in a very smart way to figure out what this problem is. And let me show you what I mean. Okay. Okay, so let's load up some queries here. I've got one particular query to show you the DMVs to track usage. Let's load that up. This is a DMV. You would use DM session space usage to find out what session is using up TempDB data. Now, in addition, I have a query to talk about this allocation ring buffer that I mentioned with this trace flag. So this allocation ring buffer is something that actually comes out of a DMV called DMOS ring buffers. So the only reason I included this for you is that if you ever wanted to query this yourself live, you could look at some of the details here. Some of the stuff even I don't understand. But what you really want to focus on is things like PFS allocation pages. That tells me how many times that a page get allocated because of TempDB usage. So this just gives you a feel for some of the details. And this X event I'm telling you about is a mirror of what's in this ring buffer. But we can be very smart about how we use the X event. So we don't have to go through all of this. So this X event session, this is one thing I am going to show you. This is an example of what it looks like. So I'm going to use this allocation ring buffer recorded event, and I'm going to capture the query for it. Now, I know by looking at that, the event itself, I know that I want this data here, this number 10 data in the event data. How do I know that? It's because I know, and I've shown you here how you can break down this event data. And 10 means PFS allocation page. You don't know that, but you look at the script to actually figure that out. So what I'm going to do effectively here is I'm going to say, hey, I want you to capture this X event, and here's where I'm using this filter. Only capture the ones where the event data is 10. So really, only capture the PFS page allocation usage. So the only time I'm going to touch the PFS page is when I'm allocating a new page. And I'm going to do 3 targets. I mentioned about this target concept. I'm going to count how many times. I'm going to also put it into a file, and I'm going to use this histogram target. And the way I'm going to do this histogram target is, I'm going to get really clever. I'm going to say, show me the histogram based on a SQL text. So what that's going to do is, it's going to record the number of PFS page allocations by query. Which query has the most PFS page allocations? And it's a way for me to know who's consuming the most of TempDB usage by using this technique. So to show you an example of this, I'll turn on this TempDB usage. I'll start it right here. Now when I start something in Management Studio after I've defined it, the different targets are available for me to look at right here. Okay? Now let's go ahead and run an example query. So I've got a database, Rangers to the World Series again, more clever American sports names. And I'm turning on that trace flag, mind you, though, right? I'm turning on the trace flag 1106 that I told you to trace this allocation. And then I'm going to run a select into for it. So I'll just run this. It doesn't take that long. And then over here, when it's finished, I can go look at the data. So for event counter, I can say view target data, and I can tell that there were these many pages allocated for this event. Well, that's not all that interesting. That doesn't tell me anything. I could look at the event file itself, which is actually fairly lengthy. That doesn't mean a lot to me either, although I do have details down here to find out queries. Because remember, I could have run a bunch of queries to do this. I just showed you one query. In your scenario, you could have like 10 people all trying to do this, right? So the actual histogram target is the one that's actually more interesting. The event file is more of just a raw trace of it. If I view target data here, notice what I have here. I actually have the actual query. So assume that I showed you a scenario where you had, I don't know, 20 different queries going on doing TempDB activity. You would see actually all the queries listed here and their counts. And then it's ordered by that count number. I would see who is the biggest user. So if TempDB was growing in its data usage, and you're maybe monitoring your server and you're not sure which query is consuming the most of these, you could actually do this by doing this histogram target and saying, oh, it's that query. Maybe you go in and look and find out, oh, they wrote it wrong and they really weren't supposed to consume that much TempDB usage. Well, maybe it's not based on just something as simple as select into. Maybe it's based on an internal usage. And by the way, based on this query I showed you earlier, let me go pull over that up. Here's the X event. Remember this query I showed you here, I can run this and I can see based on session that it's session 56 that's using user objects for TempDB. So let me get rid of that and let me show you a different one. I'm going to stop that session and I'm going to restart it. Here's a query that's running that's not using TempDB explicitly, right? But I'm doing an order by. And it just so happens I don't have an index on purpose, so I could show you this example. And if I run this now, let me get rid of that right there. If I run this, I can go back over and look at my DMV. Let me pull that back up. And I'm going to run that. Notice that this session 54 is using internal objects, right? But then I look at this and I go, well, gosh, which query is using internal objects? I want to know that. I want to know the one which query consumes the most. And I would go back to my histogram target again, view target data, and now I can tell that, oh, here it is, this select statement. Sorry, I showed the order by in here so you can see it. This select statement with an order by is the one doing it. And you might look at this situation and go like, wait a minute, that order by shouldn't have done a sort. It should have used an index, for example, and doesn't need to do a sort. Now you can do query tuning on that and figure out the problem. So this is simple examples, but you could use this on your server to go find out the queries that produce the most TempDB usage, either explicitly through temporary objects or internally through something like a sort or a hash or something of that nature. Pretty interesting. I think you might find that useful in your environment. This is a common question I've gotten from customers before. Any questions about what I just showed you? Do you understand how you can use that in your system? Okay. All right. How we're doing on time? We have 45 minutes left. Can we make it? There's another session even after this, right?
So, one question. So how
yeah.
For this question about the SQL Server edition. So, this on the first slide, we have 1,700 extended events available in 2014.
Yep.
So
all editions.
Yeah. So how are we going back? Because not everyone is using 2014 or 2012.
Yeah.
So how does
So 2008 does include extended events. That feature exists,
yeah.
But not all the SQL trace events exist there.
And how it's comparing to a provider?
Yeah, so in SQL 2008, extended events was introduced, but there's limited number of events, and SQL trace still exists. In 2012, we ported all the SQL trace events plus more to give it parity plus addition, but we didn't mark SQL trace deprecation until 2012. So in 2008, it's still not deprecated, right? So yeah, I mean, in a version like 2012 where it's deprecated, that's why we did it, to measure it up. Does that answer your question? But there's no addition difference there. There's no enterprise versus standard edition for X event. It exists in both. The comment about 2014 is just to show you how many events we've gotten to versus earlier versions.
So 2008 is quite limited, right?
It's a little more limited. There's some basic functionality in there. This isn't in there, this TempDB usage, but basic query tracing is in there. And then things like getting errors or getting weight statistics, things like that all exist there as well. So, okay. Oh, this is just a comment about how much stuff gets dumped into TempDB. And for those of you that are really crazy and want to go into the depths of TempDB, a shameless plug for a talk I did in 2011 at PASS in the US called Inside TempDB. But you can literally watch it online. You can bore yourself for 3 hours and watch slides and listen to my voice in the background talk about TempDB. So,
well, I have a question.
Yes.
In terms of extended events, RPC completed versus SQL statement completed?
They're there. Both events are there.
Duration?
It should be there.
Yeah. Do you still have different units for that?
What do you mean by different units? Oh, you mean batch versus...
One was using microsecond and the other one was using millisecond.
In X event.
In X event.
I'm not aware of that problem, so you'll have to send it to me so I can look into it. I didn't realize that we even had that difference. So RPC was micro or something and batch wasn't?
Yeah. Very, very annoying.
So that sounds like a bug to me, but so send it to me and I'll take a look at it. Okay. What about memory leaks? So, memory is a situation where, I talked even in the keynote about the fact that normally when we just grow memory, that's not a leak. But there could be some scenarios where you suspect that there might be one. Maybe you're getting message 701 out of memory errors, or you get a dump in the error log of memory status. And you're like, could there be a memory leak going on with something in SQL Server? There could be high CPU utilization going on. When there is really high memory pressure in SQL Server constantly, Resource Monitor has to do a lot of work to keep shrinking back SQL Server's memory usage, and therefore you could see high utilization because of that. And you could just find overall slow performance. When I think about looking at memory leaks, I always look at these memory clerks, right, and find out ones that shouldn't grow. For example, buffer pool doesn't normally have a leak, so it's going to grow over time, and then maybe shrink back as you hit targets, but that's not one to really focus on, right? You might look at these DMVs, memory clerks, even memory objects, and memory allocations, although this one's a little bit more advanced, requiring a trace flag. So how do you know who is using this memory and what could be causing it? Xevent has a way to help you do that. So we have this page allocated and page freed events that are available for you to trace what's going on in memory allocations. And I talked about this in my pre-con, although you all weren't in there, but the fact that SQL Server, when pages are allocated internally with our clerks, we keep track of this. Any allocation, any freed are actually happening. So you could trace this yourself, right? You could actually create an Xevent trace to simply show all the page allocated and page freed events over and over and over, and then you could get really silly by trying to manually try to figure it out. Or you could use something called a pairing target. Remember I talked about how some of our targets are smart. The histogram was an example I just showed you of a smart target. What about this pairing target? A pairing target says the following. Find two events that match each other. Allocated and freed should generally match. You allocate something and at some point you free the same that you allocated. The pairing target will say, show me the events where one occurred but the other didn't complete. So you could say these two events are paired in the pairing target, and it would only show you the ones that were allocated but not freed. That could be a memory leak. Let's show you a possible example. Okay. Oops, run that. By the way, I didn't realize that the organizers of the conference are allowed to ask questions in the session. I didn't think that was allowed.
Why not?
You can ask me later. Especially one I don't know the answer to. That's not fair.
All right.
Okay, I'm just kidding. So let me show you a couple things here. So here's a query that I have that I use to find out what memory clerk. Let me pull it up here. This is something I might use to find out what memory clerk is consuming the most pages. Buffer pool, probably on your systems is going to be the top consumer of that, right? That's normal. You might create these X event sessions that I've already built, though, in your system. One is called memory tracing. Pull that one up. Now, this is using simply the page allocated and page freed events with a, in this particular case, yeah, I thought I had this traced to a file, but I guess I just have this traced to an actual ring buffer by default. If you look on here, though, notice that I use a particular clerk name in this particular case. You don't have to. You could just put no where clause here, and it would trace all the allocated and freed events you want. If I was focusing on this particular memory clerk, which is ad hoc plans, I could do it this way. Or I might have an X event that's a little smarter doing this one. Okay? Notice I have the same events, the same clerks, but I use something called a pair matching target. And what I do is I match the page allocated and the page allocated and the page freed events based on page location, which is what we're allocating. So you allocate based on a location and you free that same location. So what I expect to see if I run a query that might be leaking is only showed page allocated events that didn't have a freed location for them, right? That's the hope. And let's see if that happens. So I'm going to turn this on. Let's see, it's pairing matching. Yeah, okay. I'm going to turn this on and start the session. And then I'm going to try to go view the data. And I see a bunch of data. So I'm like, what is going on here? I'm not sure that I really like what I'm seeing. So what I'm going to do is I'm going to run, but this is for ad hoc plans. So in this particular case, I expect to see some things in here, but not a lot. Because if I was allocating queries for ad hoc plans right now, and if I'm not running a lot of ad hoc plans, if I was running a bunch of ad hoc queries, this actually might occur because we're just caching ad hoc plans. But what if you did something like this? If I kick up this stress test and go sit here and go back and look at my pairing target data, and I start to notice something like this. Notice here the SQL text is the same over and over and over and over for a page allocated events. Now that just makes no sense to me. Why would I run a query that's an ad hoc plan query and have to allocate memory for it over and over and over and not free it? Does anybody have a guess? Probably saw a clue by what my little command name.
Probably.
What do you think it is? Yeah. So as it turns out, when you open a cursor, okay, that memory required for the cursor is stored in the same memory clerk for ad hoc plans. Okay? And so if you go and open a cursor but you don't close it, and you have your session still open, we will continue to just allocate memory over and over and over and over and never free that memory. And this is actually one of the most common user mistake scenarios I get a call on, dealing with what I call a memory leak. But the leak is your fault, not mine. And the fault is that you might have written an application that you didn't even realize you're using cursors, right? You might have just opened up a query that behind the scenes the provider uses a cursor, and you just didn't close it. You didn't close the result set, in other words, right? And you just keep doing this over and over and over and over. And this memory for this ad hoc plan cache continues to go up. And you're looking at this ad hoc plan cache going, well, you know, I just must be running a bunch of ad hoc plans. But if you see a pattern like this, we are not caching the same thing every single time, right? We're not caching the query plan. We're caching the cursor data. You have another question.
Yes, I do.
Again, even though I just asked you. I'm just kidding. What's up?
Those objects are not actual plans.
Yeah, this isn't.
Objects are not plans.
Yeah, in this particular case, the pages being allocated are not plan data. It's for the cursors themselves.
Yes.
This is why it's a little bit confusing of why you see that memory clerk increase in size. And you're like, well, that can't be the cause of my leak. There's no way that's the problem because I must just be running a bunch of ad hoc plans.
But if you queried VM exit cache plans, you wouldn't see that, right?
Yes, that's correct. You'd see one of them.
Size from the
You could query the DMV and you look for something of that nature. In this particular case, I'm showing you a technique that with just a contrived scenario where you could actually use this X event pairing target to say, well, a bunch of pages got allocated for this clerk, but it was the same query over and over and over and over. That's no way that's a cached plan, right? It must be something for this. Obviously, if you thought it might be a cursor, there's actually a DMV to see what are my open cursors, and you could go find this massive result set. Most people don't think in terms of that's what the problem is, and they don't go look at that DMV. My point is that you could use this technique for other clerks. I listed in my pre-con several leak bugs that we've got in SQL Server, and one of them deals with the optimizer clerk. Memory clerk SQL optimizer. I didn't use that scenario here because it's already fixed and I've got a build where the problem's already resolved. So that's why I created this scenario. But in that case, it's called memory clerk SQL optimizer. And that ends up being a massive clerk that's getting used for gigabytes of memory, which should never happen.
Which version?
The bug occurs in SQL 2012 and it's fixed in CU3 for SP1, which I already have a fix for, right? But if you run that scenario, you'll see that clerk optimizer be really, really high. And you're asking yourself, well, what the heck's causing that? You could use this technique to find the exact query causing the problem. And in that particular case, it deals with temporary tables used in stored procedures. So you kind of give you a feel for a technique that could be used to go detect a possible memory usage that you don't expect or a memory leak problem. Okay, we'll stop this bad boy. Okay. And you know, now that I'm talking about memory, I thought I would just throw up a slide here to give you some pointers on some memory changes that occur in 2012 if you weren't aware of this already. That we have a unified memory model. SQL OS allocates all the memory, not the buffer pool anymore. And the effect of that is that we don't have this single versus multi-page allocation scheme. And so the DMVs and memory status now have changes if you've not seen that in 2012 yet. Resource governor can apply to multi-page allocations now. And then the biggest change is max server memory means max server memory. You know, in my keynote today, I talked about the fact that we should never exceed the target, right? Well, before 2012, that actually is not true because multi-page allocations are not throttled by max server memory. But in 2012, there is no concept of that anymore. And so max server memory truly does mean max. AWE support is completely removed, so this mem to leave problem doesn't even exist anymore. Those aren't related, but mem to leave doesn't even exist. AWE is gone. Those are 32-bit issues. And then lock pages is supported on both editions, standard enterprise without a trace flag. And then one thing that I did mention in my pre-con talk that you should know about is that if you're running SQL Server 2012, and you have a NUMA system or a large memory system, I really highly recommend you consider applying our latest cumulative updates. Take a look at them at least. Several customers calling in with some issues running on SQL 2012 in those configurations. And what I mean by large, I mean something in the neighborhood of 256 or higher gigabytes of RAM or a multi-NUMA system. And then finally, Jonathan K. of MVP has reported a pretty serious problem that if you're using Enterprise Edition with CAL licensing, You've got to be careful because we actually limit the number of processors, and you can run into a NUMA imbalance problem and performance issues if you don't configure SQL Server correctly. He's got a nice blog post talking about that. So how many of you have actually used or heard of the system health session before? Anybody heard or used that? Okay. So in 2008, you mentioned about 2008, this system health session existed. And actually, it was pre-built by me, by CSS. We went to the product team and said, hey, since you're using this X event feature, we think it would be kind of cool if you built a predefined startup session for X event that had events that CSS thought was relevant to a server for its health. Hence the name System Health. Well, so it's installed by default for SQL, and it's run at server startup. So the session starts as soon as SQL starts and starts collecting data. Well, one of the problems with it is that in 2008, it was only written to write to what's called the ring buffer target. So it's only in memory. So once SQL Server was restarted, you would lose that data. Now, what's different in 2012, it's also written to a file target. And actually, it's written for rollover purposes, and there's several different files that could be kept over time. And it's got important data in it. So I want you to consider taking a look at this because there's things in here like high severity errors, deadlocks, waits, spinlock backoffs, various other types of information that we could look at if you're having a problem with SQL Server to maybe detect an issue. In 2012, we also introduced this concept called Server Diagnostics. It's an interesting concept. We built it specifically for failover clustering and always-on technologies. But as we worked on it, we realized that it could be used to look at the health of a SQL Server engine. And what it is, it's an internal stored procedure. There's a background thread that runs every 5 minutes and produces an X event based on the results of what the engine collects about itself. And the system health session has been changed to include that X event. And in addition, as I mentioned, we originally designed this for failover clustering. The result of SP Server Diagnostics is produced back to the failover cluster resource DLL to make decisions for failover purposes. So instead of just doing this simple looks alive, is alive concept, where we ran this silly query, we'd actually look at the health of SQL Server based on whether there's a lot of access violations or deadlock schedulers or something of that nature, and make smarter decisions for failover. And so I mentioned that the system health session is new as far as writing to a file target. And I would make a very, very bold statement to say that if you're having a SQL Server problem in 2012 or later, and you have no idea what's going on, the error log's not obvious, what's happening, you should collect this system health session, these files, and take a look at them, because it could provide very rich data of what might be happening in your environment. Let me just give you a little bit of a brief overview of the architecture of how this works so you can understand how valuable it could be. So this stored procedure, as I said, is internal to the engine. There's actually a stored procedure called SP Server Diagnostics, but there's no T-SQL for it. It's actually built inside our code. And it's actually scoped for the entire server, not at a database level, but at the server level. And it runs preemptively in our SQL OS system. Therefore, it's not affected by any scheduling problems or yielding problems that could be going on. So there's a background system task that by default at startup runs every 5 minutes to go run that code, to go look at the health of the server and produce some statistics. So that's called the repeat interval. If you can call this stored procedure yourself, by the way, just manually, and you can provide this repeat interval to it. And when you do that, what the procedure does is it runs forever, it never finishes, and every repeat interval, it will produce a result set. This result set is a row table format, but each row has like an XML data inside it that has rich information about the health of the server. And what happens is this SP Server Diagnostic code actually uses X event internally, and it talks to the rest of the engine. So the rest of the engine has all these statistics about how many access violations or waits that have occurred, or spinlock backoffs, or deadlock schedulers, or you name it. All this rich health of the server is collected internally. And this code is simply just taking advantage of that. And so what the code does is it says, okay, every time I run at this 5-minute interval, I'm going to produce an SP Server Diagnostic component result event. So you could write your own X event session and simply go trap that event if you wanted to, okay? The system health session does it by default for you. and it writes it to a file. So in addition to high severity errors, deadlocks, other types of information, every 5 minutes the system health session has that result set. And I'm going to show you what it looks like here in a second. Now, any TDS-based application can call that stored procedure because it's just a stored procedure, right? So in addition to this thing running in the background, when a stored procedure is called, we spawn up a different worker thread to run the stored procedure context to do the same thing based on whatever repeat interval you decide. And we return the results back to this TDS application, which again is a row-based data, but inside the data is a column that's XML. Now, one of those applications happens to be the failover resource DLL used for cluster failover. And what happens is that, they will run this stored procedure with a repeat interval of 30% of whatever the health timeout is based on your cluster failover settings. And what we have documented is that based on your failover condition level you set, and the default I forgot is 2 or something of that nature, based on that failover condition level, we will use some of the results from SP Server Diagnostics to do failover decisions. So I think the basic fundamental failover detection level is the SQL service running, basically, right? Or can you basically connect to it? Well, if you go to a more deeper level, you can cause a failover when we think we're out of memory, as an example. Or you think maybe that we're having a problem with scheduling, or spinlock backoffs, or high amounts of access violations, or something of that nature. So it's a way to do smarter failover detection without having to just rely on the fact that the service is running. Let me just show you a second here of what this result set looks like. So I mentioned to you before that the system health session right here, the system health session, is running all the time. Let me take off memory leak detection. I don't want to do that anymore. So the system health session in 2012 now has an event file. And if I go view the target data for that, notice right here, I'll sort this by timestamp. And you'll find that every 5 minutes this, that's scheduler monitor. Yeah, this SP Server Diagnostics result set is produced every 5 minutes. And what you're going to see, if you look at this, let me see if I can add in here. Yeah. For these result sets, here's the XML data that each of them have. So as an example, for the I/O system, I can see how many long I/Os occurred, like a stalled I/O for like a 15-second delay. I can see how many latch timeouts occurred because of I/O. Well, here I can see actual max workers. I can see here if I had a lot of pending tasks, that I have unresolvable deadlocks, non-yielding problems, and then look at this. I actually get the top waits in a server. So every 5 minutes, we're collecting what are the top waits by count for wait types. Async network I/O is the #1 wait type in this particular scenario. And I get the average wait time, the max wait time for each of those, CX packet, et cetera, et cetera, et cetera. I can see information about memory, and I can get things like spinlock backoffs if I think there's some sort of spinlock problem. So each of these XML result sets can be shredded, and you can find key health statistics about what might be going on in SQL Server. What we're not doing is we're not recording the worst performing queries. That's too expensive to do something of that nature. That would be kind of nice, right? I would love to know every 5 minutes what's my worst performing queries. What you see here is more of an aggregation of statistics of the health of the engine that you can take advantage of. So that's what this is. Again, by default, every 5 minutes in the system health session, or you can set up your own X event session to trap it, and then failover diagnostics uses the same data. I was going to show you in addition that by default, if you have deadlocks in your system, no longer may you need to set the trace flag, because we by default are going to collect the actual deadlocks that occur. And the really nice thing about this, without having to do a lot of analysis here, is that by default, Management Studio, if you look at this, will actually click and show you the deadlock graph. So I could go to any system that you have and find, over probably a period of a few days, what are all the deadlocks you have, and go tell you actually what's going on in the deadlock chain in your environment. That's pretty handy. without you having to go worry about turning on a trace flag and looking at this graph and the error log and kind of figuring all that kind of data out. Any questions about the system health session or SP Server Diagnostics? Let's see, we get back to here. Any questions about how that works? So I encourage you to really go back in your systems and take a look at this, this feature and this tool set. Because if you call support, I think one of the things we're going to do is ask you to send us those system health session files in XEvent so we can go look at this type of data to see what's going on. Okay, so kind of the last scenario I wanted to show you was kind of a little more advanced scenario. Got some time to show it to you, about 20 minutes. And then a few little follow-up things at the end. So there is this interesting performance problem that can occur with SQL Server. And that is, you may have a scenario where you're seeing high CPU utilization for SQL. You try to go look at the worst performing queries, and nothing stands out to you. You're like, well, I see some queries that are taking up some CPU cycles, but it's not like one query dominates the landscape. But still, CPU is very high. That is probably the most challenging problem we face at Microsoft is high CPU, the SQL Server process, and it's not to a specific worker thread or to a specific query. So what we found is over time, it's usually something called a spinlock problem. Okay? Now a spinlock is something that we use to protect shared memory structures. This is not a lock or a latch. This is a very internal concept we use. And the thinking is that, excuse me, we want to spin or loop in our code waiting for access to this memory structure. But by design, this should be extremely short. So short that it should never really cause a problem. Well, sometimes if it's not working optimally, you can get this CPU type scenario. And the reason you get high CPU, because literally in the code, think of a loop where you check for access, go to the bottom, go to the top, check for access, and you just do it in a loop fashion. So you're just chewing up CPU cycles. You're not waiting on a resource. That's why it's a higher CPU scenario if there's a problem with what we call a hot spinlock. Now the other thing we do is we don't want to just go CPU forever. So we have this concept called a backoff, where if we spin so many times, we will stop and literally do a Windows sleep call. We'll literally wait and sleep to Windows for a brief period of time. That's a backoff, and then turn around and spin again. So you can imagine if we can't access this structure very optimally, you might see a lot of this spinning, and then we'll back off and you spin again. So if you have a high number of these back-off scenarios, it's likely there's a lot of contention for this spinlock. Excuse me. Now, you can take a look at this data in a DMV called OS Spinlock Statistics, OS Spinlock Stats. And in there, you can see the number of collisions, which is the time we actually tried to get a spinlock, but somebody else used it. You can see the number of spins per collision. So if you had a collision, how many times did you spin before you acquired it? And then you can see the number of backoffs. How many times did you have to actually sleep because it was so hot, the spinlock? Now, I would say in general that you can go to any high-powered SQL server, and you're going to find spins. You're going to find collisions and spins per collision. The key is, are you seeing a lot of backoffs? And it's a really high number. And if you see something of that nature and you're having a high CPU problem, you could have an issue. And the key thing about spinlock is that generally you have no control over this. There's no spinlock hint for your query, right? This is something internal to the engine. And so we have to go try to figure out what could be the problem. And what we do in CSS is we use XEvent as a technique to figure this out. Because I can look at spinlock stats and know what kind of spinlock, but I don't know who's causing the problem. So let's try a fairly advanced demo. Now, in this particular demo, sorry, I think I have an additional comment over here. We have in XEvent a spinlock backoff event. So anytime we do that backoff, we can record it in the code, and we can use XEvent to track what's going on. And I can use this histogram target I just showed you earlier to maybe group by something to go figure out the problem. I'm not going to group by a query, though. I'm going to group by a call stack to show me in the code which sequence in our server code is causing this hot spinlock problem. Now, one comment here, as I was talking to Robert Dorr, my colleague, about showing this to you, is that we have a number of spinlocks that start with the word SOS underscore from the SQL OS system. Do not try to go track those with XEvent. Those are so internal, they're used so frequently, you could actually cause some performance problems by doing that. This particular scenario I'm showing you pretty advanced scenario. I'm going to cross my fingers it's going to work. I'm also going to tell you that this is a fix we have that we've actually made. So we fixed this in CU9, and so I've actually specifically put CU8 on my system to make sure I can repro the problem. I've got a session that I built called weight stacks. And I'm going to show you what that looks like. Yeah, right here. So this weight stacks is using that spinlock back event, and in this particular case, it's commented out here. But when I ran this before, it uses a certain type number. And you're probably asking yourself, well, how do I know what type number to use? Well, when you run the scenario, you can find out the name of the spinlock. And then you can use the mapping that I showed you. I mean, I talked about mapping earlier in the talk here. Yeah, right here. This is a DMV for X events that allows you to look up these code keys I told you about, right? Okay? And so in this particular case, I'm going to show you that this lock hash spinlock is the one that's actually chewing up the most cycles. And if you want to know what the number is to use in the X event session, because it doesn't take the name, it takes this actual number, you can use this XEMAP value to find that out. If I run this query here, I'm going to see that it's 107. That's why I had the where clause for 107. So I'm going to use the pairing target here, and I'm going to do something a little bit interesting. I'm going to actually use the call stack, excuse me, the call stack action as my histogram. So my thinking here is that I want to find the call stack that is the most sequence in the source code for SQL that's going to produce this spinlock backoff scenario. And by doing that, I should find out why is it hot? What part of the code is it hot? So let me cross my fingers and hope this works. Let me see here. Okay. So I'm going to start this session. And I'm going to kick off Okay, this is going to take a little while to run here because, and I'll explain my scenario here just in a second to you, but what I'm going to do is I'm going to show you if I start querying what happens with this spinlock stats. Sorry, let me go get that query back. I've got a DMV to do spinlock stats. So I'm going to order by collisions because I'm just going to tell you what is the hottest spinlock. And you can already see right here that this lock hash spinlock appears to be pretty hot. If you'll notice here, and then look at the backoffs are really high. So already by just running this query, I can tell. And I think what happens is my query is kicking in, but I'm pretty sure before I came into this room, I ran the demo once without restarting SQL. So I can already tell that since I haven't restarted, that this had floated to the top as my hot spinlock. These, you're probably asking yourself, well, how do I know these numbers? How do I know if spins per collision is high, or backoff is high, or spins are high, or those kind of type things? The problem is on a really heavily busy server, for collisions and spins, you don't know. But notice here in my system here that I've got some numbers in the hundreds for spins per collision for these values, but this one is floating at the top as a really hot one in the numbers of 34,000. That is an indicator that this is probably an issue going on. And then notice here that the backoffs is significantly different for this one compared to the other ones, right? So this is one probably I should go look at. While I'm running this problem, I can see just high CPU utilization going on. Let me see if this thing is finished. Yeah, it's currently just cranking away. Now, I'm going to go look at my histogram target to see what I get. And now I know what the problem is. So let me restart this event, actually. Yeah, I know. Since I've restarted my server here, let me go back here and do this. let me run this. So one of the things I got to do that you don't know, but I've got a document here for you in these scripts, is that these call stacks by their nature are just hexadecimal values. It's like meaningless to me, right? But if you take the SQL Server public symbols and put them in the bin directory where we have SQL Server, we can then set these trace flags on so that when we produce these call stacks, you can see names, actual function names. So let me go run this. Oops. Okay. Yeah, so I've got my event now, and I've got this symbolization turned on for the call stack. So let me go back. It's already running. Let me go back and run the scenario again. And I can still see that, I haven't restarted the server at this point, so Spinlock stats are still effective. I could have cleared them. You can clear Spinlock stats just like you can for latch stats or wait stats as well. Oops. Oh yeah, this should be pretty interesting. I've got a bunch of these running now, so I'm going to go over and see real quickly if I can already tell and see what this looks like. Oh yeah, so what happens here is that, I'll just start talking about my repro a little bit. I've got one program that what it's doing is it's running and opening a bunch of connections to SQL Server. Okay, that's all it's doing in life. And then over here, I've got a program that's going to go run a query against SQL Server with a lot of different users. And when I start running this query, after holding these connections open, I start getting this lock, hash spinlock, to be extremely hot. Oops, don't want to do that. Well, every time you do something, you're going to have a demo that's not going to work. Oh, yeah. Yeah, probably because I opened so many of these, but that should kick in. Ah, here we go. Yeah. So you might look at this and go like, well, this is really meaningless to me. I can't tell what all these things are. But there's some interesting information that you might find in here in this count. Let's see if I can get it right here. Yep. Right here. Now, you don't know anything about our functions names in SQL Server, but you can maybe tell by name, get shared DB lock. That might ring a bell of what this might be about. So what's happening here in this system, I'm about to show you a slide here in a second of a visualization of this, is that I've got a hot spin lock trying to acquire a DB lock. And now, why is there needed a spin lock for a DB lock? And why is even DB lock a contention point? Well, I'll explain to you why. I'll stop this because I don't want my CPU to keep spinning. I'm big about showing things in visualization, so I'll try to describe why this is an issue. This is based on an actual customer case we had to deal with. So when we have locks in SQL Server, we have this concept called hash buckets to go look up the lock resources and to keep track of the locks you're acquiring. Hashing is a concept we use for planned cache and buffer pool and things of that nature. So when you've got a database lock, the way we store this is we hash it based on the database ID and the fact that it's a database resource. So when you go and use a database, you by default get a shared database lock. No big deal. You usually don't care about that unless you need to go in and do some sort of alter database command to kick people out of the system. But when you're running SQL Server, you really don't care. So for each user that acquires a lock, we're going to store something in this lock hash list and bucketed by that same resource. Well, when there's 4 users, who cares, right? But what about when there's like 10,000 users? If you have 10,000 connections that all keep their connection open, we keep track of 10,000 database locks. Well, normally that isn't really a problem. However, what if you need to create a new user comes in and needs to insert himself in this list? Okay? The way this list works is we're going to go look up what hash bucket to go insert the lock into, and then we may have to traverse this entire list to go find the entry to either remove him or add a new one. The way we protect this list is with something called a spinlock. The spinlock makes sure the threads don't break this linked list incorrectly. So you can imagine if the list is really long, trying to traverse the list with a spinlock could chew up a lot of CPU cycles and a lot of contention points. Well, what needs to go insert this list frequently, off and on? Well, SP reset connection does. So for a pooled connection, when you close and you close your connection and reopen it, we actually have to go in and reset the database context. So if you've got a scenario where one set of your app keeps a lot of connections open, okay, and you've got this list really long, and then a lot of reset connections are happening very quickly on a highly scalable server, you can run into the contention with this spinlock just because of the fact that you have this huge list. And so we talked to this customer and we're first like, well, why are you keeping all these connections open? That's kind of silly. We're like, well, we have to for our application needs. Well, why is reset connection running so frequently? Well, what we found that they were doing is they were using pooled connections, but they would connect, run a query, and disconnect for every query they ran. And we said, well, that's not really all that efficient. And they said, yeah, but it's really hard for us to go change our app code to do this. What are we going to do? Because this is killing our server. So we made a fix. And this is how we fixed it. We actually created and we partitioned this lock resource by CPU now. So now the picture looks like this. For each CPU, there's a separate list for this database shared lock. So whatever CPU you're running on, we only have to use the list for that CPU now. And so now the spinlock becomes a lot less of a problem because you only need a spinlock for a shorter list, depending on what CPU you're running on. And because we only let one user run at a time on a scheduler, in effect, you're not going to have any collisions for this spinlock anymore because each person on their own CPU just runs one at a time. And that was the story about how we actually found out this problem by using the technique I just described to you. We saw it was a lock hash spinlock. We didn't know what was going on. We used this X-event technique to find the call stacks. We quickly found this code about shared DB locks. And then we were like, what is going on here? And then we quickly ran into the situation and recognized that if this list is really long and somebody has to go in and pull your shared database lock out and pull it in and out very quickly, you can have contention. And this really becomes a problem as you have more CPUs. This issue up here, because you have more people running at the same time that could all touch this list. So in this situation, the customer was on a 32 CPU machine, no problem. Went to 128 CPUs and bam, they had major collisions here. And then by this technique, they have no issues anymore at all. In fact, their CPU utilization went from like 75% to 10 just based on this fix alone. So, any questions about that technique? It's a fairly advanced technique. Yes, sir?
Where was it fixed?
CU9. So in the slide decks, whenever I do this kind of type of things, I'll give you a link to where this problem is. So if you click here, when you get the deck, it'll point to the article where this 2012 SP1 CU9. That's correct.
Right. So is it also existing in 2008?
Yes, and we backport these fixes naturally as the next CU comes out. So.
What about lock hash collisions on data hotspots?
So you can have some lock hash collisions on some other types of locks, but we actually partition some of the other ones already. So for example, table locks are naturally partitioned.
If I query the same data row from 100 threads, will I have lock?
Yeah, we partition locks for those already naturally. We didn't do it for databases because we didn't think anybody cared. So some of the other lock types you're talking about, you won't see hotspots on Spinlocks for those because we already partitioned those naturally. Okay, so I thought you might find that interesting. That's really, I'm about 2 minutes early. Oh, that's really weird for me. I'm 2 minutes early. I've got some references about how we use X events in various scenarios, some other information behind some of the different aspects of X event. I hope I gave you a pretty good feel of different scenarios, some of them a little bit more advanced. But the live server scenario I showed you in the beginning is just for basic performance troubleshooting. As I mentioned, there's some 700 of these events. Some of them are pretty esoteric. When you look at something called the channel, which is a category of events, we break these down into debug, analytic, operational. The debug events are the more advanced ones. Sometimes you don't want to use those. This Spinlock backup happens to be one of those. But some of the other ones are very interesting. Let me just give you an example. If you had a lot of page splits going on, and you had no idea what query was causing it, you can use Xevent to figure that out. You can set up an event, record the page split, add an action for the SQL text, and then you can figure out, well, which queries are generating the most page splits. There's all sorts of opportunities for you to use these instrumentation points to find out key information about your server. Any other questions that you have here before we conclude? Yes, sir?
Well, we have this problem, and so basically we are using reporting services, and every week, between 2 hours, we want to send around 7,000 emails, and it's data-driven subscriptions. So what happened is that we are getting a lot of errors that the connection pool cannot pull the connection from the connection pool.
Okay.
And I think even 2 weeks ago, basically the server was failover because it was not accessible. So, what would you recommend to actually find out exactly,
Like why the failover occurred?
Yeah, and the second question is, because I know that there was a bug in that, I think SSRS or SQL Server, that the connection was not closed in the connection pool.
Okay.
And I think it will fix in Service Pack 2, but we have Service Pack 2 and it's still,
Yeah, I'm not aware of that bug. If you ask me just about failover in general, if it's 2012, for example, you have this SP Server Diagnostics result set that's produced by default. And what's really cool about failover clustering for 2012 is we produce the result set in 2 different ways for failover clustering. One, we produce the system health session I just mentioned, but also the failover cluster resource detail produces a separate X event that is the return results of SP Server Diagnostics and includes in there the decision it made to do the failover. So there could be key statistics in there to tell us, well, maybe it was some massive blocking problem, or maybe it was something to do with running access violations. I'm trying to remember some of those scenarios we run into, or I couldn't get a worker thread or something like that. So there's key stats in the cluster logs for 2012 that can tell us why we did a failover. I don't know if it's based on your connection pooling problem, but that's where I would start, besides just looking at your error log in general. And that's why we added it in 2012. But if you have a specific scenario that's not addressing, that you think, send me an email directly. I'm happy to help you take a look at that. Any other questions about this topic? Did you find it useful? Some information useful for you? Great. I hope you enjoy the rest of your day. Finally, you're going to get lunch sometime, maybe this afternoon or whatever. And I look forward to seeing you at the rest of the conference. Thank you very much.